Okay, so we're back to determining the area of surface generated about the y-axis, given the function y is equal to 2x as x goes from 0 to 2. And just taking, okay, what we have here. Okay, so you still have f of x is equal to 2x, or y is equal to 2x, and this will be going from 0, 0 to 2, 4. And if I am looking at integrating with respect to y, okay, so I can just rewrite y is equal to 2x as x is equal to 1/2 of y. And if I'm going to integrate with respect to y, so I can just take for y is equal to 2x, I can write this in terms of x, where x is equal to 1/2 of y. And taking the derivative with respect to y on both sides, so we have dx over dy is going to be equal to 1/2, and in taking the square of the derivative, so you have dx over dy quantity squared. Okay, so this will be equal to 1/4. And all right, and we have generating the solid about the x-axis. And so this time around, if I'm integrating with respect to y, we have for the projected radius. Okay, so we're going to have that p of y is equal to y. So again, the vertical distance, okay, away from the x-axis, okay, to the middle of this inscribed rectangle is going to be y, kind of like what you would have with the method of shells. Now, and for what we have regarding, okay, this version of determining the area of surface generated about the x-axis in the version of integrating with respect to y. Okay. So again, we have in the rewrite, so we're going from y is equal to c to y is equal to d. And we have 2 pi times p of y, and I have times the square root, and we have 1 plus dx over dy quantity squared dy. And filling in what we have with the limits of integration. Okay, now when I integrated with respect to x, I went from x equals 0 to x is equal to 2. But now in this particular case, I'm going from y is equal to 0 to y is equal to 4. So I have different limits of integration. So I have going from y is equal to 0 to y is equal to 4. And I got 2 pi. And again, p of y is equal to y. And I have times the square root. And I have 1 plus, okay, 1/4. And working with what we have now. So I have going from y is equal to 0 to y is equal to 4. So I have 2 pi y. And I have times the square root of 5/4 dy. And again, 4 is a perfect square number, 5 is not. So just in taking what we have and following through, so I have 2 pi y, I have times the square root of 5, square root of 4 is going to be at 2, and here we're going to have the 2's to cancel out, and for following through, okay, so I have what's going to be, so I got pi y square root of 5, and so we have pi y squared times the square root of 5 over 2. Again, just going back to the power property of integration. And this will be as y goes from 0 to 4. 0, the expression is negligible. For 4, we have 4 squared is 16 over 2 is 8. And once again, we have for the area of surface generated about the x-axis, we once again have 8 pi times the square root of 5 square units.